This demonstration will show how to set up a mode expansion monitor and interpret the mode expansion results. This is the structure with the wide ridge waveguide as the input waveguide, followed by a taper and a narrower output waveguide. The device acts as a polarization converter, converting the mode from first order TE mode at the input waveguide to the fundamental TM mode at the output. The efficiency of the conversion increases as the taper length is increased. We will use the mode expansion monitor to determine how much of the power at the output has been converted to the fundamental TM mode at the output, and what fraction is still traveling in the first order TE mode for this particular length of the taper. A frequency domain field and power monitor has already been set up at the output to measure the fields to use for mode expansion. Set up the mode expansion monitor. Start by adding a mode expansion monitor from the Monitors drop-down menu. Edit the monitor and set the geometry to match the position of the frequency domain field and power monitor. Set the X position to 2.6 microns, the Y position to 0, and the Y span to 4 microns, the Z position to 0, and Z span to 3 microns. Next, in the Mode Expansion tab, click the Add button to select the monitor to expand fields from. Double-click on Select Monitor and select the Power Monitor. You can also write a name to use for the expansion results to indicate the monitor that the results correspond to. I will use the name Output since the monitor is located at the output waveguide. Under the mode selection on the left side of the window, choose User Select. This will allow me to calculate a list of modes and select multiple modes of interest. Click the Select Modes button, then in the window that pops up, click the Calculate Modes button. I want to know the fraction of power traveling in both fundamental TM mode and first order TE mode, which are the second and third modes in the mode list. With one mode selected, I can press the Control key on my keyboard and select additional modes using the mouse in order to multi-select modes. Once the two modes in the mode list are selected, click the Select Modes button to accept. Click OK to accept the monitor settings. Next, click the Run button to run the simulation. After the simulation has completed, right-click on the Mode Expansion monitor and visualize the expansion for output result. This result contains multiple different sets of data, so I'll simplify the plot by removing all but one result so I can focus on one result at a time. Across the x-axis of the plot, the value n is plotted, and n corresponds to the mode number of the selected modes of interest of the mode expansion monitor. Since I selected the second and third mode, which correspond to fundamental TM mode and first order TE mode of the output waveguide, there's data for n equals 2 and n equals 3. For the T-total result, which gives the net power transmitted through the field monitor in all modes, this is a constant value over n, since the result is for all modes and not a specific mode that you've chosen. The result is close to 1, which means that almost all power flowing through the monitor is traveling in the positive x direction. Next, double-click on the attribute and select T forward. This gives the power traveling in the positive x direction in each of the selected modes. So almost 80% of the power is still traveling in the first order TE mode, and only less than 20% of the power has been converted to the fundamental TM mode. T backward gives the power traveling in the selected modes in the negative x direction, which is very small. T net is T forward minus T backward. Here are some tips for setting up mode expansion monitors. For broadband simulations, you can set up the mode expansion monitor to calculate the modes for expansion at multiple frequency points over the wavelength range. Typically 3 to 5 frequency points is sufficient, and this does not have to match the number of frequency points measured by the monitor for expansion, since the mode profiles will be interpolated onto the frequency points measured by the monitors. The expansion calculation between the fields and selected modes is done relative to the center position of the mode expansion monitor and frequency domain field monitor, so it's important to make sure that both monitors are centered around the same relative position in relation to the waveguide. A single mode expansion monitor can be used to expand the fields from multiple frequency domain field monitors as long as the cross-section of the waveguide or fiber is constant. For example, here, the ring resonator has 4 ports, and the expansion for all 4 ports can be done by one mode expansion monitor, since the waveguide cross-section is the same at all ports. The Align to Frequency Monitor Center option in the Mode Expansion tab needs to be selected in order to perform the overlap when the position of the waveguide at the mode expansion monitor and field monitor for expansion are offset. To get accurate mode expansion results, it's important that the span of the monitor is large enough to include the full profile of the supported modes of the waveguide or fiber. Otherwise, the calculated modes that will be used for expansion won't actually represent the real supported modes of the structure. You can check this by plotting the mode profiles and making sure that the fields decay to 0 by the edges. If a fine simulation mesh is used, and many modes are selected for the mode expansion calculation, the data of the calculated mode profiles may cause the simulation file size to be large, even before running the simulation. If you want to reduce the file size, you can clear the calculated mode data using the Clear Mode Data button and choose the User Select Mode Selection option so the mode profiles are not automatically calculated when you save the file. Changes can be made to the mode expansion monitor settings while in analysis mode after running the simulation to modify the mode expansion results to calculate. For example, you can edit the mode expansion monitor and select additional modes of interest to get the expansion results for more modes than were originally selected without having to rerun the simulation. Finally, for most applications where mode expansion results are required, the port objects are easier to use than mode expansion monitors. The port objects will be covered in more detail in the following subsection. In contrast to mode expansion monitors, which require the use of a source object, frequency domain monitor, and expansion monitor, the ports combine all 3 into a single object.